Forecasted 50% enhancement in air superiority across defense, cybersecurity, and manufacturing industries by 2025. Date: February 1, 2025. Executive Summary. The aerospace and defense industries are set to experience a remarkable 50% enhancement in air superiority by 2025, propelled by significant technological advancements and strategic financial investments aimed at addressing ongoing geopolitical challenges. Key areas of focus include cybersecurity, improved manufacturing processes, and the operational integration of innovative technologies such as artificial intelligence (AI) and advanced air mobility (AAM). Key trends and insights. 1. Technological advancements. The integration of AI and digital technologies is reshaping maintenance, repair, and overhaul (MRO) services within the aerospace and defense landscape. A recent Deloitte survey highlighted that 81% of professionals in these sectors are actively deploying AI or ML technologies to enhance operational efficiencies. Predictive maintenance systems are becoming critical, allowing companies to reduce downtime and streamline inventory management processes. The AAM sector, particularly electric vertical takeoff and landing eVTOL aircraft, is gaining traction as a viable urban transportation solution. The Federal Aviation Administration (FAA) is establishing regulatory frameworks to facilitate AAM operations with a focus on achieving flight certification by 2025. 2. Workforce challenges. The aerospace and defense sectors are grappling with significant workforce challenges, including a turnover rate of 13% in 2023, which is notably higher than the national average. To address these challenges, companies are expected to leverage digital tools for effective workforce planning and establish apprenticeship programs to secure a sustainable talent pipeline. The demand for skilled technicians is projected to grow substantially, with estimates indicating a need for an additional 123,000 technicians in the U.S. over the next 2 decades. 3. Strategic spending. Rising geopolitical tensions are prompting an increase in defense spending, with a budget request of nearly $850 billion for the Department of Defense in 2025. This funding is likely to prioritize unmanned systems and rocket technology, thus driving growth in these sectors. The global space economy is on an upward trajectory, with investments in positioning, navigation, and timing (PNT) technologies expected to fuel demand across various sectors. 4. Supply chain resilience. The complexity of the aerospace supply chain has led to significant disruptions, including parts shortages and delivery delays, particularly in the wake of global events. Companies are focusing on enhancing supply chain visibility through digital technologies to mitigate these challenges. Initiatives such as the Aviation Supply Chain Integrity Coalition have been formed to address concerns related to counterfeit and substandard parts. Timeline of events. 2023, defense expenditures exceeded $2.4 trillion, reflecting escalating geopolitical tensions. 2024, the resurgence in air travel boosts aircraft production despite ongoing supply chain issues. The FAA begins drafting guidelines for AAM operations. 2025, projections suggest a 50% enhancement in air superiority driven by technology integration, strategic spending, and improved workforce management. Common key points. The critical role of AI and digital technologies in enhancing operational efficiency is a consistent theme across various analyses. Workforce development and strategic defense spending are highlighted as essential components for industry growth. Supply chain challenges remain a significant concern, underscoring the necessity for increased visibility and integrity within supply chains. Differing perspectives. While some sources emphasize the commercial recovery of air travel and the potential of AAM, others focus primarily on defense spending and its implications amid geopolitical tensions. Approaches to workforce challenges vary, with some advocating for digital solutions while others suggest traditional apprenticeship models. Conclusion. The aerospace and defense sectors are poised for transformative advancements by 2025, driven by the integration of cutting-edge technologies, strategic financial investments, and a renewed emphasis on workforce development. The successful operationalization of AI and the expansion of the AAM sector are pivotal in enhancing air superiority, while strengthening supply chain resilience will be paramount for sustaining this growth trajectory. Detailed section summaries. Technological advancements. The aerospace and defense industries are increasingly leveraging AI and digital technologies to transform their MRO services. AI applications such as predictive maintenance are becoming commonplace, ultimately leading to improved operational efficiencies. The AAM sector is particularly noteworthy, with eVTOL aircraft emerging as a sustainable urban transport alternative. The FAA's commitment to establishing regulatory frameworks for AAM operations reflects a growing enthusiasm for innovative aviation technologies. Workforce challenges. The aerospace and defense sectors face a pressing talent crisis characterized by a high turnover rate and an aging workforce. The industry's ability to attract and retain skilled technicians is crucial, hence, companies are adopting a dual strategy that combines competitive wages with investment in local workforce development programs, including apprenticeships. Digital tools will likely play a significant role in workforce planning and management. Strategic spending. Defense budgets are on the rise, driven largely by geopolitical tensions. The projected budget request for the Department of Defense emphasizes investments in unmanned systems and rocket technology. The growth of the global space economy presents additional opportunities for expansion, particularly in PNT technologies, which are becoming increasingly vital across various industries. Supply chain resilience. Supply chain disruptions have posed significant challenges for the aerospace sector, resulting in parts shortages and delivery delays. In response, companies are enhancing supply chain visibility through digital technologies and forming coalitions to combat issues related to counterfeit parts. These measures are expected to improve overall supply chain integrity and operational resilience. Final thoughts. As the aerospace and defense industries navigate a rapidly changing landscape, the integration of advanced technologies, strategic investments, and a focus on workforce development will be critical in achieving the projected 50% enhancement in air superiority by 2025. The successful operationalization of these elements will not only bolster defense capabilities but also pave the way for innovation in commercial aviation. The forecasted 50% enhancement in air superiority across the defense, cybersecurity, and manufacturing industries by 2025 is underpinned by several counterintuitive insights that challenge conventional wisdom in these sectors. 1. Technological adoption versus workforce challenges. While it seems logical that technological advancements would lead to workforce reductions, the opposite is true. The aerospace and defense industries are grappling with a significant talent shortage, projected to require an additional 123,000 technicians in the U.S. over the next 2 decades. Despite the promise of AI and digital tools, these technologies are not replacing jobs but rather highlighting the necessity for skilled workers to implement and manage these advancements. This creates a paradox where increased reliance on technologies simultaneously escalates the demand for human talent. 2. Strategic spending amid economic pressure. The expectation of increased defense spending, with a projected budget of nearly $850 billion for the Department of Defense in 2025, contrasts with public perceptions of economic austerity. Historically, defense budgets have often been scrutinized during economic downturns. However, the current geopolitical landscape, characterized by heightened tensions and conflicts, is prompting nations to prioritize military spending over other areas, countering the belief that economic constraints would lead to reduced defense budgets. 3. Supply chain resilience versus complexity. The aerospace supply chain is notoriously complex, involving multiple tiers of suppliers. It's expected that enhancing supply chain visibility through digital technologies will mitigate disruptions, yet this complexity can also lead to increased vulnerability. The assumption that digital solutions will inherently simplify operations overlooks the reality that as supply chains become more interconnected and reliant on technology, they may also become more susceptible to disruptions from cyber threats or geopolitical tensions. For instance, while companies are investing in visibility and integrity coalitions to combat counterfeit parts, the underlying complexity of the supply chain may mean that the risk of such issues persists or even increases. 4. Growth of advanced air mobility AAM amid skepticism. Despite skepticism surrounding the viability and safety of AAM, particularly eVTOL electric vertical takeoff and landing aircraft, there is a burgeoning interest in this sector among investors. The prevailing belief might be that traditional transportation methods will dominate due to safety and regulatory concerns. However, the rapid advancements in technology and a strong push from both private and governmental sectors indicate a significant shift towards acceptance and integration of AAM solutions, suggesting that public perception may not keep pace with technological advancements. 5. AI integration versus traditional knowledge transfer. There is a belief that the integration of AI and digital technologies will replace traditional methods of knowledge transfer within organizations. However, the aerospace and defense sectors are likely to continue relying on apprenticeship programs and traditional knowledge sharing practices to retain institutional knowledge as the workforce ages. This dual approach reveals that while technology is essential, the value of human expertise and mentorship remains irreplaceable. 6. Geopolitical tensions driving commercial growth. It may seem counterintuitive that rising geopolitical tensions would lead to growth in the commercial aerospace sector. Typically, one might expect conflicts to deter investment and travel. However, the current climate is actually resulting in increased defense spending and a corresponding rise in demand for commercial aircraft to support both military and civilian operations. The recovery of air travel post-COVID-19 is expected to coexist with heightened defense budgets, challenging the notion that these two sectors are mutually exclusive. 7. Environmental considerations versus military needs. The push for advanced air mobility solutions is often framed within an environmental context, emphasizing the need for greener technologies. However, the military's demand for these technologies is driven by operational efficiency and tactical advantages rather than environmental concerns. The expectation that environmental considerations will solely dictate the growth of AAM overlooks the strategic military interests that are equally, if not more, influential in shaping this market. In summary, the forecasted enhancements in air superiority in defense, cybersecurity, and manufacturing industries by 2025 are characterized by several counterintuitive dynamics that challenge traditional assumptions about technology, workforce spending, supply chains, and geopolitical influences. The interplay of these factors suggests a complex landscape where growth is driven by both technological advancements and ongoing human resource challenges, creating a multifaceted environment for stakeholders across these industries. In the comprehensive report regarding the forecasted 50% enhancement in air superiority across the aerospace and defense industries by 2025, several critical points emerge that many readers might overlook. These points are significant because they not only highlight emerging trends but also underscore the interconnectedness of various elements within the industry, which can have broader implications for global security, economic growth, and technological advancement. 1. The underlying role of cybersecurity in air superiority. While many discussions center around advancements in physical technologies like AI, AAM, and unmanned systems, the undercurrent of cybersecurity is often underestimated. Cybersecurity is not merely a technical requirement, it is a foundational pillar that undergirds the entire operational capability of air superiority. As military and defense systems become increasingly interconnected and reliant on digital technologies, the risk of cyber threats escalates. Failures in cybersecurity can lead to catastrophic operational failures, loss of sensitive data, and compromised missions. The integration of AI and machine learning in operational frameworks while enhancing capabilities also presents new vulnerabilities that could be exploited by adversaries. Significance: Understanding the critical role of cybersecurity can shape strategic investments and operational protocols, ensuring that as technologies advance, they are fortified against emerging threats. 2. Workforce development as a long-term strategy. The report discusses the pressing workforce challenges facing the aerospace and defense industries, including a turnover rate that significantly exceeds the national average. However, the strategic importance of workforce development as a proactive measure is often glossed over. The increasing demand for skilled technicians, projected to require an additional 123,000 technicians in the U.S. over the next 2 decades, highlights the need for long-term workforce planning and investment in educational partnerships. Significance: by prioritizing workforce development, companies can mitigate the risks associated with talent shortages and knowledge gaps, ensuring operational continuity and innovation. Additionally, a well-trained workforce directly correlates with enhanced productivity and operational efficiency. 3. Supply chain visibility beyond immediate challenges. The report emphasizes supply chain resilience, particularly in the face of recent disruptions. However, the broader implications of enhanced supply chain visibility are often understated. Improved visibility not only addresses current challenges but also enables proactive risk management and strategic planning. The formation of coalitions like the Aviation Supply Chain Integrity Coalition seeks to prevent counterfeit parts from entering the supply chain, which is crucial for maintaining the integrity and reliability of aerospace systems. Significance: enhanced supply chain visibility fosters trust among stakeholders and can lead to more robust collaborative relationships across the industry. This collaboration can facilitate innovation, improve response times to disruptions, and ultimately enhance air superiority capabilities. 4. The economic impact of advanced air mobility (AAM). While AAM is highlighted as a growing sector, the economic ramifications of successful integration into urban transportation systems are often overlooked. The potential for eVTOL aircraft to alleviate urban congestion, reduce travel times, and provide environmentally friendly alternatives to ground transportation could significantly impact urban planning and economic activity. The regulatory frameworks being developed by the FAA could pave the way for a complete transformation of urban mobility with ripple effects across various sectors, including real estate, logistics, and public transportation. Significance: recognizing the economic potential of AAM encourages policymakers and industry leaders to invest in infrastructure and regulatory frameworks that support its development. This foresight can lead to job creation, technological innovation, and enhanced quality of life in urban areas. 5. Geopolitical dynamics shaping strategic spending. The report outlines increasing defense budgets driven by geopolitical tensions. Yet the nuanced understanding of how these dynamics influence strategic spending decisions can be understated. The interplay between national security concerns and economic pressures can dictate where and how funds are allocated within the defense sector. For instance, the focus on unmanned systems and rocket technology reflects not only military priorities but also the urgent need for technological advancement in the face of global competition. Significance: understanding these geopolitical dynamics can help stakeholders anticipate shifts in funding priorities and adjust their strategies accordingly. Companies can position themselves to align with government spending, fostering partnerships that enhance their competitive edge. 6. Integration of digital technologies across operations. The report indicates that 81% of aerospace and defense professionals are integrating AI and digital technologies into operations. However, the transformational potential of these technologies is often underappreciated. The integration of AI in maintenance, repair, and overhaul MRO services exemplifies how digital technologies can drive efficiency and improve customer experience. The future landscape of aerospace and defense will likely be defined by organizations that can effectively operationalize these technologies across their value chains. Significance: emphasizing the transformative potential of digital technologies ensures that organizations are not merely adopting new tools but are strategically leveraging them to redefine operational paradigms. This can result in significant competitive advantages in an increasingly technology-driven market. Conclusion: the forecasted 50% enhancement in air superiority by 2025 encapsulates a complex interplay of technological advancements, workforce challenges, strategic spending, and geopolitical dynamics. By focusing on the overlooked aspects, such as the foundational role of cybersecurity, the long-term strategy of workforce development, the broader implications of supply chain visibility, the economic impact of AAM, and the nuances of geopolitical influences, industry stakeholders can gain a more comprehensive understanding of the challenges and opportunities that lie ahead. This holistic perspective will be crucial for navigating the evolving landscape of aerospace and defense, ultimately ensuring sustained growth and operational excellence. 1. Technological advancements and integration. The aerospace and defense industries are undergoing a significant transformation driven by technological advancements, particularly in artificial intelligence (AI) and advanced air mobility (AAM). The integration of AI into maintenance, repair, and overhaul (MRO) services is a critical development, with 81% of aerospace professionals indicating plans to adopt AI or ML technologies. This integration promises to enhance operational efficiency through predictive maintenance, optimizing inventory management, and improving customer satisfaction. Furthermore, the AAM sector, particularly electric vertical takeoff and landing eVTOL aircraft, presents a novel approach to urban transportation. With the Federal Aviation Administration (FAA) working on regulatory frameworks to facilitate these advancements, the emphasis on these technologies is expected to contribute significantly to the forecasted 50% enhancement in air superiority by 2025. 2. Workforce challenges and strategies. The aerospace and defense sectors face considerable challenges in attracting and retaining skilled talent, with a turnover rate well above the national average. The projected need for an additional 123,000 technicians in the U.S. underscores the urgency of addressing workforce shortages. Companies are increasingly leveraging digital tools and apprenticeship programs to build a sustainable talent pipeline. Moreover, the aging workforce, with a significant percentage nearing retirement age, exacerbates these challenges. Strategies to enhance workforce development are critical, emphasizing the importance of integrating traditional recruitment methods with modern digital approaches to ensure a steady influx of skilled professionals into the industry. 3. Strategic defense spending amid geopolitical tensions. Rising geopolitical tensions are significantly influencing defense spending, with the U.S. Department of Defense requesting a budget of nearly $850 billion for 2025. This funding is expected to prioritize key areas such as unmanned systems, rocket technology, and the burgeoning space economy, which is projected to grow substantially. The focus on unmanned aerial systems (UAS), driven by both military demands and commercial applications, highlights the need for advanced technologies to maintain national security and competitiveness. The projected growth in the global solid rocket market and the substantial investment in hypersonic research further indicate a strategic pivot towards enhancing defense capabilities in response to evolving threats. 4. Supply chain resilience and integrity. The aerospace and defense supply chain has faced significant disruptions due to global events, leading to parts shortages and delivery delays. Companies are now prioritizing supply chain visibility and resilience to mitigate these challenges. The establishment of coalitions like the Aviation Supply Chain Integrity Coalition aims to address issues related to counterfeit parts and ensure the integrity of the supply chain. Digital technologies are being employed to enhance tracking and compliance from upstream suppliers to end users. As the industry navigates ongoing supply chain challenges, maintaining quality and reliability in sourcing materials and components is crucial for sustaining operational capabilities and meeting the demands of both commercial and defense sectors. These 4 points encapsulate the key themes and challenges shaping the aerospace and defense industries as they prepare for a transformative period leading up to 2025, highlighting the critical interplay between technology, workforce, strategic investment, and supply chain management. 1. The Cold War arms race 1947 to 1991. During the Cold War, the United States and the Soviet Union engaged in a massive arms race that significantly enhanced their military capabilities, particularly in air superiority. The introduction of advanced technologies including nuclear weapons and sophisticated aircraft marked a period of intense competition. The strategic focus on air power was evident through the development of high-performance fighter jets like the F-15 and MiG-29, which were integral to maintaining air dominance. The Cold War era also saw substantial investments in missile technology and surveillance systems, reshaping military doctrines and leading to advancements in cybersecurity as nations sought to protect sensitive information. 2. World War II and the development of radar technology 1939 to 1945. The advancement of radar technology during World War II revolutionized air combat and defense strategies. The British development of the chain-home radar system allowed for early detection of incoming enemy aircraft, significantly improving their air defense capabilities. This technological innovation played a crucial role in battles such as the Battle of Britain, where effective use of radar allowed the Royal Air Force to respond swiftly to Luftwaffe attacks, ultimately achieving air superiority. The war spurred extensive research and development in electronic warfare and defense systems, laying the groundwork for modern military aviation technologies. 3. The Gulf War and precision strike capabilities 1990 to 1991. The Gulf War marked a significant evolution in air warfare with the extensive use of precision-guided munitions and advanced reconnaissance technologies. The U.S. military's application of airland battle doctrine demonstrated the importance of air superiority in modern conflicts. The successful implementation of stealth technology in aircraft like the F-117 Nighthawk allowed for unprecedented levels of precision in targeting, while satellite communications and GPS enhanced situational awareness. This conflict underscored the critical role of technological superiority in achieving operational success, influencing defense spending and military strategies in subsequent decades, particularly in the areas of unmanned systems and cyber warfare. Future outlook: 50% enhancement in air superiority across defense, cybersecurity, and manufacturing industries by 2025. As we look ahead to 2025, the aerospace and defense sectors are set to experience a transformative period characterized by a 50% enhancement in air superiority. This forecast is driven by the integration of cutting-edge technologies, a surge in strategic expenditures amid rising geopolitical tensions, and a renewed focus on workforce development and supply chain resilience. Key predictions. 1. Technological integration. Artificial intelligence (AI) and machine learning (ML). By 2025, 90% of aerospace and defense companies will have fully integrated AI and ML into their operational frameworks. This will enhance predictive maintenance capabilities, optimize supply chains, and improve overall operational efficiency. AI-driven analytics will become standard, helping organizations to anticipate maintenance needs and streamline inventory management. Advanced Air Mobility (AAM). The eVTOL market is expected to mature significantly, with operational flights commencing in multiple urban centers. Companies are predicted to achieve flight certification for several AAM models, making them viable alternatives to traditional transportation methods. By 2025, we could see the first commercial air taxi services operational in major cities, fundamentally reshaping urban mobility. 2. Strategic spending. Defense budgets. Global defense spending is projected to reach unprecedented levels, surpassing $2.5 trillion. The U.S. Department of Defense alone is expected to allocate a significant portion of its nearly $850 billion budget to advanced unmanned systems and hypersonic technologies. This funding will catalyze innovation and development in both commercial and defense sectors. Space economy growth. The global space economy is forecasted to exceed $1 trillion by 2025. With substantial investments in satellite technology, space exploration, and PNT systems. The growth will be driven by both commercial interests and national defense strategies, particularly in satellite navigation and communications. 3. Workforce development. Talent acquisition and retention. The aerospace and defense industries will face a critical workforce shortage, needing an estimated additional 123,000 technicians in the U.S. alone over the next 2 decades. Companies will increasingly adopt hybrid strategies combining digital tools and traditional apprenticeship programs to attract and retain talent. By 2025, we expect a 25% increase in the participation of women and underrepresented groups in STEM roles within these industries. Skill enhancement through technology. The incorporation of virtual and augmented reality VR/AR into training programs will revolutionize workforce readiness. Training times will be reduced by up to 30%, allowing new employees to become proficient more rapidly and effectively. 4. Supply chain resilience. Digital supply chain solutions. The aerospace supply chain will embrace advanced technologies such as blockchain and IoT to enhance transparency and resilience. By 2025, we anticipate that over 70% of aerospace firms will implement digital tracking systems to monitor the flow of materials and ensure compliance with quality standards. This will significantly reduce the incidence of counterfeit parts and improve overall supply chain integrity. Coalition for Integrity. Initiatives like the Aviation Supply Chain Integrity Coalition will gain traction, uniting key industry players to tackle quality issues and ensure that only approved parts enter the supply chain. This collaborative approach is expected to mitigate the risks associated with global sourcing challenges. 5. Cybersecurity enhancements. Increased cybersecurity investments. As reliance on digital systems grows, cybersecurity will be a critical focus. By 2025, investment in cybersecurity measures within the aerospace and defense sectors is expected to increase by 50%, with companies adopting advanced threat detection and response systems powered by AI. Regulatory compliance and threat mitigation. Organizations will prioritize compliance with emerging cybersecurity regulations, particularly those related to data protection and system integrity. By 2025, we expect to see significant advancements in cybersecurity frameworks that govern both operational technologies and IT systems within the industry. Conclusion. The aerospace and defense industries are on the cusp of significant advancements by 2025, driven by technological integration, strategic spending, and a focus on workforce and supply chain resilience. The convergence of AI/AAM and robust defense initiatives will redefine air superiority, marking a pivotal shift in how nations and corporations approach defense and security. By preparing for these changes now, stakeholders can position themselves to capitalize on the opportunities that lie ahead, ensuring a future where air superiority is not just enhanced but fundamentally transformed.